Okay, this is question 30A of the 2015 CSSA trial mathematics paper. It says Valentine has a reaction time of 1.8 seconds. He is driving at 70 kilometers per hour when he sees a hazard in the road. He applies the brakes and comes to a stop after 23.8 meters. Okay, then he goes on to ask, what is Valentine's reaction distance in meters? Now, this is actually quite a straightforward question, but people get bogged down with this type of question based on just a simple misconception and not realizing you need to have the same units. So if we're talking about the reaction time of 1.8 seconds, but he's driving at 70 kilometers per hour, obviously this is in seconds, this speed is measured in hours. So it implies that, it doesn't imply, it tells you basically you're going to have to make some sort of conversion. And to determine what sort of conversion you're after, just read the rest of the question. I mean, it's asking you for his reaction distance in meters. Okay, and to work out a distance, you go to your trusty triangle. So distance is equal to speed times time. Okay, so you need a speed and you need a time, a speed that is in meters per second, and the reason it's meters per second is because the reaction time is 1.8 seconds. So your speed has got to be in meters per second, and the reason it's meters is obviously it's asking you for meters. Okay, so you've got a time in seconds and you've got a speed at the moment in kilometers per hour. So what needs to happen before you do anything is you've got to convert this speed into meters per second, just so that you can comply with what they're asking you to find in terms of meters. Some people just throw the numbers in without taking note of the units, and that's where they go wrong. So 70 kilometers per hour, I've got to convert that into meters per second. So simple case of how many meters in a kilometer? 1,000. So therefore 70 kilometers is 70,000 meters. Okay. How many seconds in an hour? Well, 60 minutes by 60 seconds. Okay, so that's how many seconds you got. So basically you got 70,000 meters per 3,600 seconds. So you want to get meters per second, so you want a unit there. So if you divide both sides by 3,600, okay, you trust the calculator. 70,000 divided by 3,600. That gives you 19.4 recurring. Okay, you can just use that exact value in your calculator. You can save it or what have you. So basically your speed is 19.4 recurring meters per second, and I mean I've still got the value on my calculator, so I'm not going to delete it because I know I'm still going to use it. But just for simplicity, I mean you can express the speed like that in your working. Okay, so now the distance. The distance would be 19.4 recurring multiplied by the time, which is 1.8 seconds. So using the value you got on your screen, multiply that by 1.8 equals 35 meters. Okay, so the reaction distance is 35 meters. And what that means is, if this bloke Valentine has got a reaction time of 1.8 seconds, so that means it takes 1.8 seconds for him to react to situations. It means in this scenario, if he's traveling at 70 kilometers per hour, in that time that he's reacting, or he's going to have a reaction distance of 35 meters. So over that 1.8 seconds, he's going to travel 35 meters. And that does not mean he stopped. That just means that while he's reacting in that 1.8, he's traveling still at 30. He's traveling for 35 meters. Okay, and just note in terms of my working out, I didn't retype 19.4 times 1.8 because you're going to lose accuracy. I just used what value I had on my screen, because that's the exact value, and I multiplied by 1.8, and that's why I've got the 35 meters. Okay, pretty straightforward. But just be careful. Once again, it's all about matching up the units, and that's basically what you're getting tested on. They give you all this blurb, but really the basic maths is making sure you're working in the appropriate units. Of course, you've got to know how to find the distance that something's travelled, but the main thing here is the units. Okay, part 2. Use the fact that stopping distance is equal to reaction time distance. So reaction time distance, which is what you've got up here, because that's what you found, reaction distance in meters, plus braking distance to calculate Valentine's stopping distance. Now, the braking distance you're already given, because it tells you up here, he applies the brakes and comes to a stop after 23.8 meters. So that is the braking distance, 23.8 meters. Okay, it's just being aware of what they're giving you in the question. So if he applies, as soon as he applies his brakes, obviously he's not going to stop instantaneously. What they're saying is, if he's been traveling at 70 kilometers per hour, it's going to take him 23.8 meters to actually come to a stop. So to calculate his total stopping distance, you've got to look at the reaction time distance, so the 35 meters that it takes him to react, plus the stopping distance when he actually has applied the brakes. So to calculate that, it's as simple as stopping distance is equal to reaction time distance, which we calculated up here, it's 35 meters, plus the braking distance of 23.8 meters. And that works out to be 58.8 meters. And that's it. Pretty straightforward, easy 2 marks, but people do get caught out and do lose marks here purely because of not taking note of the units. Don't rush these questions, just make sure you've got the right units, look at what they're asking for and what units they're asking, and it's pretty straightforward. Okay, that's that one.